Howdy. 2 hours ago, on phys.org, where did Earth's water come from? Not melted meteorites, according to scientists. Water makes up 71% of Earth's surface, but no one knows how or when such massive quantities of water arrived at Earth. The new study published in the journal Nature brings scientists one step closer to answering that question. Led by University of Maryland Assistant Professor of Geology Megan Newcomb, researchers analyzed melted meteorites that had been floating around in space since the solar system's formation 4.5 billion years ago. Hence the Big Bang. In other words, the paradigm in which they are moving seems already completely wrong. But anyway, they found that these meteorites had extremely low water content. In fact, they were among the driest extraterrestrial materials ever measured. In other places where you read stuff about meteorites and stuff like that, they are described as dirty ice balls. No, here they say they didn't find any water. These results, which led the researchers rule them out as the primary source of Earth's water, could have important implications for the search for water and life on other planets. It also helps researchers understand the unlikely conditions that aligned to make Earth a habitable planet. We wanted to understand how our planet managed to get water, because it's not completely obvious, Newcomb said. Getting water and having surface oceans on a planet that is small and relatively near the sun is a challenge. The team of researchers analyzed 7 melted anchorite meteorites that crashed into Earth billions of years after splintering from the last 5 planetesimal objects that collided to form the planets in our solar system. In a process known as melting, many of these planetesimals were heated up by the decay of radioactive elements in the early solar system's history, causing them to separate into layers with a crust, mantle, and core. Yeah, I don't know if does it make any sense. You can read the rest, because there's some other stuff as they wanted to talk about. Where did she set this one thing? Yeah, here. We wanted to understand how our planet managed to get water, because it's not completely obvious. Maybe it is. And why I said this? First, we go to the plasmauniverse.com. No plasma, no 99.999% of the universe. No plasma, no universe. Birkeland current. A Birkeland current usually refers to the electric currents in the planet's ionosphere that follows magnetic field lines, i.e. field-aligned currents, and sometimes used to describe any field-aligned electric current in a space. Plasma. They are caused by the movement of plasma perpendicular to a magnetic field. Birkeland currents often show filamentary or twisted rope-like magnetic structures. They are also known as field-aligned currents, magnetic ropes, and magnetic cables. Originally, Birkeland currents refer to electric currents that contribute to the aurora, caused by the interaction of plasma in the solar wind with the Earth's magnetosphere. The current flows earthwards down the morning side of the Earth's ionosphere around the polar regions, and spacewards up the evening side of the ionosphere. These Birkeland currents are now sometimes called auroral electrojets. The currents were predicted in 1903 by Norwegian explorer and physicist Christian Birkeland, who undertook expeditions into the Arctic Circle to study the aurora. Yeah, 120 years ago. Professor Emeritus of the Alphen Laboratory in Sweden, Carl Gunnar Feldhammer, wrote in 1986, a reason why Birken currents are particularly interesting is that, in the plasma force to carry them, they cause a number of plasma physical processes to occur. Waves, instabilities, fine structure formation. And these in turn led to consequences such as acceleration of charged particles, both positive and negative, and element separation. Both, I said both, sorry. Such as preferential ejection of oxygen ions. Both of these classes of phenomena should have a general astrophysical interest far beyond that of understanding the space environment of our Earth. Okay, so we came from the mystery of why and how we have water on Earth to the Birken currents, and now let's have a quick listen to Dr. Donald Scott. Dr. Donald Scott, Intergalactic Birken Currents.
Markland was and is now a very well-known astronomer, ex-astronomer in Sweden, and he came up with the idea that if the voltage plot in a Birken current is linearly decreasing, as we saw this was, then positive ions will be accelerated outward and create a high temperature region at the outer boundary of the BC. That's what we just said. So what? Well, Markland said, neutral atoms are not affected by voltage or E field. They're neutral. They don't sense any force. So they just diffuse around the place. And so neutral atoms of all elements will diffuse into the BC. Why stay out? I mean, there's no force on them, so they're pretty much equally diffused through there. But the elements with the highest ionization values, and that sort of counterintuitively is hydrogen, oxygen, and nitrogen. You see, hydrogen, gee whiz, it only has one electron. It must be easy to knock that out, to ionize it. No, it's tough. Iron is much easier. This is 32 or 36 or whatever. What's the valence number of iron? It's got a gazillion electrons, and it's very easy to pop one out. So it turns out that iron will be found in the cooler part, the center. And hydrogen, oxygen, and nitrogen will be found on the outside. So says Markland, anyway. Well, I kind of like that because that results in something that looks very similar to a Birken current. And it says that elements with the lowest values of ionization will be at the center, but the hydrogen, that's the important one, will be found in the periphery. Again.
So, to the next part, a self-made picture or collage. Maybe you have seen this, maybe not. It's made really sketchy. I have no idea how to draw straight lines with a cell phone on some whatever picture, so the lines aren't straight. Yeah. Sometimes I tried harder, sometimes not, so they are what they are. But anyway, that's our Earth, obviously. The deepest quake ever recorded, 987 kilometers. And the diameter is somewhat 12,742 kilometers. And I took a picture from lab plasma because I think it's possible that we would have a plasmoid at the center of Earth. The Birken currents which go through the Earth are not in the picture. And at the center would this plasmoid. However big or small it would be. But there would be space within Earth for such a thing. And Earth would be much like a geode, but alive, you know? This part here, which is somehow reaching outwards, could be compared to a part like this, or this, or this, or this. These would be places where we would find volcanoes. So now, and of course, the plasmoid is only possible if we somehow apply the model of Wald-Thornhill's repellent core. And now to the next picture. Maybe it's not actually the one I wanted to show you, but that's another one I made once. That's a geoid. Obviously you can see, or hopefully you can see. I tried my best to make it invisible. I drew even South Africa there and stuff. The thing in the center here, that's a dust devil screenshot what I made from the La Palma eruption. You can find videos about this, I think, somewhere. I made videos about that. And we see the Birkeland currents, or the Birkeland current going through Earth. So now that's a screenshot from the Donald Scott video we just saw. Here we have hydrogen, oxygen, and nitrogen. And in the picture, like we have north and south poles. So let's say the Birkeland current goes vertically through our planet. We have to remember there's no up or down. In the universe, it's just our perception. But anyway, you get what I mean. But if there is a plasmoid within Earth's core, we somehow, or I at least, think that the plasmoid might have a somewhat similar structure like this Birkeland current here. There would be just a connection from above and below. Again, there is no above or below in the universe, just here on Earth. But anyway, so you are watching basically now from above into the Birkeland current. So there would be, let's say, Antarctica. You get it. And I will not show you the Birkeland current simulator, but I wanted to show you something else. I drew north and south here. So you have to imagine the Birkeland current would go like this. But if there's a plasmoid in the center, there might be a sphere-like shape, which might have the same distribution of the elements, because it is in a way a spherical Birkeland current. And check it out. We have hydrogen, oxygen, and nitrogen. Hydrogen and oxygen makes the water. And there is this thing called the MOHO. It is some layer within Earth's crust where the conductivity something is changing rapidly. And I think it's some kind of a double layer. Maybe it is a double layer for the hydrogen. Below the MOHO there is no hydrogen or oxygen. So all the stuff accumulates on the outer layer. As we can see, on the outer layer it is blue, because it's H2O. Yeah, this is stuff I ponder about, or upon. So is the MOHO some double layer within Earth where beyond that downwards is no hydrogen or oxygen, so all the stuff just accumulates on the surface as clouds and surface water, and of course the water in the ground. Just flipping a Birkeland current model, 90 degrees. And probably you get the solution. Because it's there in plain sight. Now back to the article. We wanted to understand how our planet managed to get water because it's not completely obvious, Newcomb said. Getting water and having surface oceans on a planet that is small and relatively near the sun is a challenge. Maybe it's not that big of a challenge. But this is just what I think. I am no scientist, so... Don't believe me, make up your own thoughts. And, yeah, thanks. Bye.